Now we are going to study about sequence detection. Okay, so now we need to detect a particular sequence. So let's just say this is my particular input 110 110 110 110 11. This is the input, and you are giving this input to a sequence detector which detects the following sequence 110 11. So what output you will receive? So output will be of two types. One will be when overlapping is not allowed, and one will be when overlapping is allowed. So let's see the example, you will understand more. Okay, so this is the input applied. Okay, here you can see you need to detect the sequence 11011, and overlapping is not allowed here. Overlapping is not allowed. So what will happen? First this one will come. You need to generate this sequence 11011 11011. So output will be 0. Then 11 will come. Again output will be 0. Then 110 will come. Sequence will keep on coming. Then again output will 0. Then 1101 will come. Again output will be 0. Then 11011 will come. Okay. Now output will be 1 because this sequence has been generated. Now what the question is saying? Overlapping not allowed. Overlapping not allowed means just as this has been generated, your register will be clear. All these values will be clear. Now nothing is there. 110 has been generated, nothing is there. Now next 0 will come here. Directly 0 is come. 0 is coming. These are gone. So output will be 0. Then 1 will come. Output will again be 0. Then 1 will come. Output will again be 0. Then 0 1 1 0 will come. Output will again be 0. What do you need to generate? 110 11. Then 0 1 1 0 1 will come. So 110 11 you need to generate. So output will again be 0. Now how many bits are there? 5. And this detector detects 11011. This detector which we are designing, it is detecting 11011. So that means there are 5 bits, right? So in the register as well there has to be 5 bits only. So in the next cycle what will happen? 0 1 1 0 1 and then another 1 will come, but it will clear this. Okay, in the register there can be only 5 bits. Are you getting this point? If it is detecting 5 bits only, so in the register as well, in the register you can have only 5 bits. So here 11011 is coming, so that means yes, it is detected. So you will receive this output. Okay. So when you feel like that there are being 6 bits in the register, then you need to eradicate one. Okay. So now just as it has been detected, so it will be all clear. Then 0 will come, again 0. After that 0 1 will come, again 0. Then again 0 1 1 will come, so again 0. So that's the output you are receiving. Okay. So this is the output you will receive. Well and good. So first 0, then 1, then 0 0 0 1 0 0 0. So this is the case of overlapping not allowed. So actually what happened is that first it detected this sequence, then it detected this sequence. So 2 times your output was 1. 2 times your output was 1. If overlapping was allowed, then what was the scene? Overlapping allowed, the same sequence I need to detect. So what do you think what will happen? So first it will detect this sequence 11011. Then again you can see 11011. Then again you can see 11011. Then again here you can see 11011. So 4 times your output will be high. Let's check. First what will happen? 1 will come, 0. Then 1 1 will come, 0. Then 1 1 0 will come, 0. Then 1 1 0 1 1 will come, 0. Till then everything is same. Till this cycle everything is same. Now 1 1 will come, 1. Till this also everything is same. Now just as this cycle comes, just as this is being detected, when it was overlapping not allowed, it was getting cleared, but here it will not get cleared. What will happen is that in the next cycle 1 1 0 1 1 and next 0 will come, but it cannot have 6 bits because in the register you can only have 5 bits, so it cannot have 6 bits. So this one it will clear. So now you are having 1 0 1 1 0 1 0 1 1 0. Output will be still 0. In the next state this one will be cleared, so 0 1 1 0 and 1 will come. So again output is 0. Then in the next state this 0 will be cleared, so 1 1 0 1 1 will come. Yes, it is being detected. So if it is detected, your output is 1. Now in the next cycle, this one will be gone. So 1 0 1 1 0, output is 0. Then in the next cycle, this one will be gone. So 0 1 1 0 1. Okay, output will be 0. Then in the next cycle, this 0 will be gone. So 1 1 0 1 1. Yes, output is 1. So this is also detected. Okay, I should have written it more small. Let's do anything. Can we do anything? Yeah, it works. Okay, I hope you will be able to understand it. So 1 1 0 1 1 is coming. Till this point we have reached. Okay, till what point we have reached? Till this point we have reached. Okay, 1 1 0 1 1. Now in the next cycle this will be cleared. So 1 0 1 1 and then 0 will come. So again 0. Then in the next cycle this will be cleared. So 0 1 1 0 1 will come. So again 0. In the next cycle 1 1 0, this 0 will be cleared and 1 1 will come. So this is again detected. So this is also 1. So what is your output? 0 0 0 1 0 0 1 0 0 1 0 0 1. So 4 times you will be getting 1. So if in the question this is asked that how many times your output will be 1. So better you will see, okay, overlapping allowed 1 2 3 4 in that manner. Here we saw now 1 2 3 and 4. 4 times your output will be 1. And here overlapping is not allowed. So once, then all clear. Then start looking from here, not giving, this is giving, and again 1, all clear. Then start looking from here, not giving, okay, only 2 times. So these kind of questions are asked usually in your gate examination. But we will study about the designing as well. That is a very important part and very intuitive. And usually people find it very difficult, and usually it is ignored as well. But we will see the in-depth analysis. We will see whatever that can be covered. So in the next video that we will see. But we will see the designing part as well. How to design overlapping and non-overlapping sequence detector using Mealy machine, using Moore machine. Okay, so that we will see in the next particular video. But let's solve a gate problem. So a sequence detector is designed to detect precisely 3 inputs with overlapping sequence detectable. For the sequence overlapping, overlapping is allowed. You need to detect the sequence 101 and input data is 1101. So input data is, okay, I need to add a page. So input data is 110 110 100 110 100 110 101 10 101 101 10 10. Okay, so I will see again 100, sorry, 110 100 110 110 100 110 101 10 101 10. Okay, okay, then, and you need to detect the sequence 101 101. So first 1 will come, output will be 0. Then 1 1 will come, output will be 0. Then 1 1 0 will come. What I need to detect? 101 I need to detect. 101 I need to detect. Again output will be 0. In the next cycle what will happen? 101 will come. This one will also come, right? 110 and then another one. But this will be cleared. Why this will be cleared? Because only 3 bits can be there in the register. So yes, output will be 1. Okay. After that, this one will be gone, 010, output will be 0. Then this will be gone, 100, output will be 0. Then this will be gone, 001, output will be 0. Then this will be gone, 011, output will be 0. Then this will be gone, 110, output will be 0. Then this one will be gone, 101, yes, output will be 1. After that, where we have reached 101, so this will be gone now. So 010, output will be 0. This 0 will be gone. I hope you are able to catch up. Okay, 101 we have reached, 010. Now 010, now this is gone. 1 0 1, this will be again 1, then this one will be going 0 1 1, so this will be 0. After that 0 will be gone 1 1 0, this will be 0 only, and after that you will be left with 2 bits, certainly it is 0, then 1 bit, certainly it is 0. So what is the output sequence you are having? 0 0 0 1 0 0 0 0 0 1 0 1 0, and then 3 times 0, right? But in the option, what do you see? In the end you see only 2 0, and in the beginning you only see 1 0. Why is that so? Because usually in the options what they can do is that they will check the output only when there are 3 bits in the register. So only these outputs they are checking. Okay. So usually this is what they can do. Only these outputs they are not considering these 2 0, they are not considering these 2 0. So this 0 and this 0 they are not considering, and this 0 and this 0 they are not considering. So 0 1, then 5 times 0, 0 1, then 5 times 0, then 1 0 1, and then 2 times 0. So that's the output you are getting. So this is the option A. So this is how the options can be framed, where they will not consider the states where you are having less than 3 bits. Here you are having 3 bits, so they will consider it. But if you are having less than 3 bits, they will not consider the states. So here you are having 1 1 1 1, but they are not considering these 2 states, okay, and these 2 states as well. So this may happen in the options. So for this particular example, what could be the option given? They will not consider this state, they will not consider this state, they will not consider this state, they will not consider this state. They will consider the state where you are having 5 bits input. Okay, 5 bits should be there. So 5 bit is there, 5 bit is there, 5. So they can give the output as 1 0 0 1 0 0 1 0 0 1. There you go. Okay, so this is how they can frame their output. So they can consider 5 bits. So these kind of questions can be framed in your GATE examination. Even in the interview as well, they can ask these kind of questions, and even in what we say, even in your written examination of placement also, these kind of questions can come. So I hope you must have understood this particular concept, that is the how do we detect a particular sequence, overlapping allowed, overlapping not allowed. And the important thing is you need to see that only 5 bits will be there in the register if we are detecting the 5 bits, and if we are detecting the 3 bits, there should be 3 bits in the register. Okay, and in case of overlapping allowed, the register doesn't get cleared, it will keep on going 5 5 5 5 5. But in case of overlapping not allowed, once you detect the sequence, all gets cleared. Once I have detected the sequence, everything is getting cleared. I am again starting from 0, again starting from the next bit. Okay, so I will start right from the beginning. Once I detect a particular sequence, I will start right from the beginning. So that's a very important point. It will be highly used in our next video. So what I am saying? I am saying that in case of overlapping not allowed, once you detect the sequence, your register gets cleared. You start again from the beginning, that is 0. So here I am starting from here. Okay. So in case of overlapping allowed, your register doesn't get cleared, only one of the bits is removed, you again see there are 5 bits altogether. Okay, then in the next video we are going to study about designing a particular sequence detector. How do we design a particular sequence detector? So very important point, very important topic, and you need to give me full concentration, then only you will be able to understand it. Okay, then so let's meet you in the next video. Next video will be very interesting. Thank you very much. Hi everyone, we have been studying about sequence generation and detection. So in the last video we saw everything about sequence generation. So we saw the circuit as well, and we saw the meaning of sequence generation as well. Then we were studying about sequence detector. So there we saw that there will be 2 kind of outputs, overlapping allowed, overlapping not allowed. So there will be a sequence detector circuit, you will apply a input bit stream. If overlapping is not allowed, it will detect the sequence once and twice. So twice it will detect the sequence, and if overlapping is allowed, then first it is detecting, then again detecting, then again detecting, and then again detecting. So 4 times it is detecting. Okay, so there were 2 cases, overlapping allowed and overlapping not allowed. So basically there will be a state machine, or you can say there will be a circuit to which you will apply some input. Just as you have applied the input, it will start giving you the output, right? If the sequence is detected, in this case it is detecting 1 1 0 1 1. Just as it is detected, it will give output 1. In case of overlapping not allowed, just as it is detected, very important line, just as the sequence is detected, the whole register gets empty and you start right from 1 bit. Just as the sequence is detected, it will completely get empty and you will start right from the beginning again. In case of overlapping allowed, just as it is detected, it is not getting empty, it is carrying the previous bits. Just as it is detected doesn't carry the previous bits, doesn't carry previous bits, in next cycle. Very important point, the whole lecture will be based on this only. Okay, carries previous bits in next cycle. Very important point. Okay, and oftenly it is ignored by the aspirant. If they are asking good question from you, then this concept will be used. So let's start designing our sequence detector. Now what is our task? Our task is to design this particular machine. Here we saw how it will give the output, but how we will design this? This also we will design. We know how output comes. This is the input stream that user will apply, but how to design this, that we are going to see now. So now we are going to design sequence detector. So for a particular sequence, let's just say I need to detect 11011. So for this particular sequence, detection, there can be 4 type of machines. 4 type of machines are possible. Overlapping allowed, overlapping not allowed. And in case of overlapping allowed, Mealy machine. Overlapping not allowed, Mealy machine. Overlapping allowed, Murray. Non-overlapping, Murray. Right? To detect a particular sequence, there could be 4 type of machine. Overlapping allowed, Mealy. Non-overlapping, Mealy. Overlapping allowed, Murray. Non-overlapping, Murray. Okay. Now this statement you will not understand as of now, that the number of bits in the sequence, let's just say if number of bits, this is the sequence that I want to detect, 11011. So how many bits are there in the sequence? 5. So in case of Mealy type, you would require 5 states only. There are 5 bits, right? There are 5 bits. So in case of Mealy type, you would require 5 states. And in case of Murray type, you would require 6 states. One more state. When we see the example, it will be more clear to you. Just I wanted to write down this point because this is also very important point. Okay. So in case of Mealy, equal to the number of bits, and in case of Murray, one more than that. So let's start with our first example now. So which sequence you need to detect? You need to detect the sequence 11011. Okay. So number of bits are 5. So let's just say I am in any state. I am in state A. This state could be anything, 000, this 001, 01, 101. It could be any state. But currently I am in state A. I am starting from state A. This is my starting point. This is my starting point. Now, if my applied input is 1, what I am doing, this is my FSM. This is the state that I am designing, and from here I am applying the input. If my applied input is 1, then I will be happy, because if applied input is 1, then I can go to the next state now. Because if applied input is 1, then I am on right path. So if applied input is 1, then I can go to the state B. Next state I can go, which is my state B. What will be the output I will be giving? 0 output only, no? I will not be giving but 1 output until I detect the complete sequence. Until I detect the complete sequence, I will not give 1 output, right? You see here, overlapping not allowed case we are doing. Overlapping not allowed case. Until you detect the complete sequence, you are not going to give output 1. Okay. So this is the overlapping not allowed case we are seeing now. Okay, overlapping not allowed. Then again, if I get 1, if my applied input is 1, then I can go to the next state C. If my applied input is 0, then I can go to the next state D. And if my applied input is 1, then I can go to the next state E. So basically the scene is, if I am at B, that means sequence 1 has been detected. Okay. If I am at state C, that means certainly sequence 11 has been detected. If I am at state D, that means certainly 110 has been detected. If I am at state E, that means certainly 1 1 0 1 has been detected. Say yes or no. If I am at state B, 1 has been detected, then only you are coming to B. If you are at state C, then 1 1 has been detected. If you are at state D, then 1 1 0 has been detected. If you are at state E, then 1 1 0 1 has been detected. Now, if I apply input 1 again, I am at state E. If I get 1 again, then my job is done, right? My output will be 1 now. My job is done. If at state E I apply input 1, then job is done, output will be 1. So if the job is done, in case of overlapping not allowed, in case of overlapping not allowed, if the job is done, we start our work right from the beginning again. Just as the job is done, we will start the work right from the beginning again. So just as the job is done here, just as the job is done, it will start the work again. So if 1 is applied, it will give output 1 and will start the job again. 1 1 0 1 1. So this sequence has been detected. 1 1 0 1 and 1. And just as you get this sequence, your output is 1 now. Okay, but we need to take other cases as well. What if the first input was 0 only? If applied input was 0 only, you will come back to the same state. You will start from A only, because if applied input is 0, you cannot proceed. Now if you are at state B, that means 1 has been already applied. If you are at state B, that means input has been 1 already, that's for sure. In the next state, if I get 1, then I know I need to go ahead, because that is the sequence that we want. But what if I get 0? If I get 0, then what I will do? If I get 0, then I know that I have to go back to again A only. If I get 0, I will have to go back to again A only, because I will have to start right from the beginning again. If I get 0, then I will have to start right from the beginning, because what I am gonna do is that I will drop 1 bit, I will look for this bit, which is 0. Do I see 0 anywhere? Do I see 0 here? No. Do I see 0 here? No. Do I see 0 here? No. The complete bit has to be 0. That I do not see anywhere. Here I get 0, but there are 3 bits, no. So there is no state which is already giving me 0. No, nothing like that. So I will come back to state A only. What about C? In case of C, if I get 0, then I will go to the next state. If I get 0, then I will go to the next state, that is D. That I know. But if I get 1, then where will I go? What do you think? Will I go to A, or will I go to B, or will I come back to C only? What do you think? If I get 1, if I get 0, I am proceeding. If I get 1, then where will I go? What do you think? Look, here you can see, if you drop 1 bit, here you can see double 1. And where you are getting double 1? You are getting double 1 at C only. Basically, if you are at C, that means certainly you have already got double 1. Now you are waiting for the next input. If next input applied is 0, then you are going to the next state. If next input applied is 1, then what you will think? That these two bits are still useful. Why these 2 bits are useful? Because let's just say I get this sequence. My first applied input was 1, then again it was 1, then again it was 1, then it was 0, then again 1, then again 1. So here it will say that the sequence has been detected. So these 2 bits have been used, and it will start from C only. After C, it will see that 0 is applied, I will go to D. After that, it will see that 1 is applied, I will go to E. After that, it will see that 1 is again is applied, I will go back to A. So what you need to do, basically, how we see it, how you can do it quickly, that is, now I am at state C, that means 1 1 has been applied. If 0 is applied, I know I need to go ahead. If 1 is applied, then I will drop 1 bit, I will look for these 2 bits. Do I get 1 1 anywhere? Yes, I get 1 1 in C only. So if I apply 1, my output will still be 0, sequence is not detected, but I will come back to C only. What about D? 1 1 0. If 1 is applied, I am going to the next state. But if 0 is applied, I will drop 1 bit, I will look for 1 0 0. Do I see 1 bit 0 0 here? No. Then I will look for 0 0 only. Do I see 0 0 here? No. Then I will look for single 0. Do I see single 0 here? No. That means I will have to go back to state A only. So I will have to go back to state A again. Okay. So if 0 is applied, output will be 0 and have to go back to state A. What about E? 1 1 0 1. If 1 is applied, I will have to go back to state A, because my sequence will be completed, my output will be 1. But if 0 is applied, If 0 is applied, what I will see? I will drop one bit. I will see, do I see 1 0 1 0 anywhere? 1 0 1 0, no. Do I see 0 1 0 anywhere? 0 1 0 here? No. Then I will look for last 2 bit. Do I see 1 0 anywhere? 1 0 here? No. Do I see single 0 here? No. That means certainly I will have to start right from the beginning again. So better making another line. It is written in this manner only, that just a second, I will keep this a bit here, and it is written in this manner only, that if 0 is applied, you will go to state A giving the output 0 only. Then again full cycle you have to start. So this is the state diagram. I know it is not very easy, like people will make it very complex. Okay, this is very tough to understand as well, that also I know, but we have understood the concept behind it, and now we have made a way to make this table. What is that way? That first you write down the condition, that how you are going to proceed when you are getting the one output, then you see which all bits have been remaining. Okay, and based on that you see in which state you are going. Okay, let's take another example. Overlapping not allowed only in case of Mealy. Overlapping not allowed, you need to detect 1 0 1 0. Overlapping not allowed in case of Mealy, you need to detect 1 0 1 0. So this is my starting point. I am starting from state A. If 1 is applied, yes, I am happy, because 1 0 1 0 I need to detect. So if 1 is applied, I will go to the next state. Then if 0 is applied, then I am happy, I will go to the next state. Then if again 1 is applied, I am happy, I will go to the next state. Then again if I am at A, that means this is my starting. If I am at B, then certainly 1 has been detected. If I am at C, then 1 0 has been detected. If I am at D, then 1 0 1 has been detected. If applied input is 0, then my job will be done and I will be coming back to A only. If applied input is 0, job is done, I am coming back to A only. Right? Now, in the initial only, if I am getting 0, so this is not what I want, I will start again here at B. If I get 0, I know I need to go ahead, right? But if I get 1, what I will do? I will drop one bit, I will see, do I get 1 anywhere? Yes, I get 1 in the state B only. So if applied input is 1, I will give output 0, but I will come back to state B only. Why I am not going to A? Why should I start from the beginning? Because this 1 can be used in the next analysis, in the next stage. To go for the next state, this 1 can be used. That's why I am not going to state A again. I am staying at state B only. Because what if the sequence is 1 1 0 1 0? So this 1 can be used. So that's why I got to know that B, if I am at state B, that means 1 has already been applied. So why should I start from A? I will start from B only, no? Right? Now let's come to C. If I come to C, what do I know? That if 1 is applied, I need to go to the next state. But if 0 is applied, then I will have to think. So what do I see? That do I get double 0 anywhere? No. Do I get single 0 anywhere? No. Then certainly I will have to start from A only. Because this sequence can never be used. Anyhow, this sequence can never be used. Let's just say next bits are 1 0 1 0. So this 1 0 1 0 will be detected. There is no use of that. So certainly you will have to start from A only. Are you getting this point? Slowly you are understanding, right? Now I am at state D. So if 0 is applied, I know I need to go here. But if 1 is applied, now I will look for the best case. Which is the best case? Let's see. 0 1 1. 0 1 1. Do I get 0 1 1? No. Do I get 1 1? No. Do I get a single 1? Yes. So this 1 is of some use. This 1 can be useful for me. So where I am getting? At state B. So from here to, I will go here. Are you getting this point? In the last state 1 0 1. If 0 is applied, I will have to start right. If 0 is applied, my job is done. Now I will start from the beginning. But if 1 is applied, then I will look for the best case. 0 1 1. 0 1 1. 0 1 1 not getting. 1 1 again not getting. Single 1, yes I am getting. So this 1 can be of use. Single 1 I am getting here. So I will go to this state. So if applied input is 1, then output will still be 0 and I will go to this state. Now let's just say if this diagram is given in front of you and they ask you which sequence it will detect. Can you tell that? Which sequence this state diagram will detect? Yes, we will start from A. You will see when do I go to the next state? when applied input is 1. When do I go to the next state? When applied input is 0. When do I go to the next state? When applied input is 1. And when do I get the final output? When applied input is 0. There you go. This is the sequence that is detected. So this is how you can do. Okay. These kind of questions are easy, but if they are asking to design, that becomes a bit typical. But designing part is also important. Okay, because that can be used. Now what else can be asked? So here there were 4 bits, right? 4 bits. 4 bits means you require 4 states. And 4 states means how many flip-flop you require? 2 flip-flop, right? Basically your A can be 0 0, B can be 0 1, C can be 1 0, and D can be 1 1. So how many flip-flop required? 2 flip-flop required. In this case, number of bits were 5. That means 5 states were there. 5 state means how many flip-flop? 3 flip-flop you require. Okay. So they can ask you to detect this particular sequence, how many flip-flops you will require. So what you will do? 5 bits are there. That means there will be 5 states. If 5 states are there, then certainly 3 flip-flops will be required. In case of Mealy, whether it is overlapping allowed or not allowed. In case of Mealy, this will be the answer. Now let's see the case of overlapping allowed. Now overlapping is allowed. In case of overlapping allowed and overlapping not allowed, what was the difference? Till this point everything was same. But when the sequence was detected, at that time there was difference, right? When sequence was not detected, there was no difference. But when the sequence was detected, after that the difference came. What was the difference? This guy was starting right from the beginning again. Right from the beginning again. But this guy is not starting right from the beginning. It will carry the previous bits. It will carry the previous bits. And in the next cycle, what do we go to know? That this double one has been used. You can see that this double one has been used. This double one has been used. This double one has been used. So that has been used. So previous bits can also be used. Even after detecting the sequence, previous bits can also be used in case of overlapping allowed. Okay, so now we are going to make the cycle for, or we should say state diagram for the case of overlapping allowed. So now your overlapping is allowed. So what I am going to do, what I need to detect? 1 1 0 1 1. I will start from A only. If applied input is 1, I am happy, I can move to the next state. If applied input is 1, again I am happy, I can move to the next state. If applied input is 0, I am again happy. I am again happy and I can move to the next state. Did I write 1 here? No. ये सब blunder तो नहीं किया ना मैंने. Yeah. Now if I applied input is 1, then I can move to the next state. And now if my applied input is 1 again, so here I will pause. Okay, so we will analyze this. So if I am at B, then that means 1 has been detected. If I am at B, then 1 has been detected. If I am at C, then certainly 1 1 has been detected. If I am at D, then 1 1 0 has been detected. If I am at E, that means 1 1 0 1 has been detected. Right? Now if applied input is 0 at E, I am talking about at E. If my applied input is 0, sequence is not detected now, right? Sequence is not detected. 1 1 0 1 0. This is not you wanted. You wanted 1 1 0 1 1. So if applied input is 0, sequence is not detected, then it will look for best possible case. What is that? 1 0 1 0. Getting anywhere? No. 0 1 0. Getting anywhere? Wait a second. So at state A, I am at 1 1 0 1. So if 0 is detected, if applied input is 0, so if it will look for the best case. 1 0 1 0, are you getting anywhere? No. 0 1 0, are you getting anywhere? No. 1 0, are you getting anywhere? No. 0, are you getting anywhere? No. So it will start right from the beginning only. This is the case for if applied input is 0, then sequence is also not detected. Also you have to start right from the beginning. Now if my applied input was 1, now it will again start looking for the best case. Why it is starting? It will start looking for the best case. If your applied input is 1, you know one thing, that is my output is going to be 1 now. If my applied input is 1, if my applied input is 1, my output is going to be 1. But where it will go? It will go to the initial state. No, this is the case of overlapping allowed. If overlapping is allowed, then you see here the overlapping was allowed. So it was not starting from the beginning. It looked for the best case that these two 1 1 can also be useful for me. These two 1 1 which I am getting in this state, these can also be useful for me, because what if in the next states I get 0 1 1? So now it will look for the best case. So here. So if I am at state E, that means 1101 has been already detected. Now if 1 is applied, it will start looking for the best case, which is, do you see 1010 anywhere? No. Do you see 011 anywhere? No. Do you see 11 anywhere? Yes, I see 11 at state C. So it will go to the state C. Are you getting this point? Because 11 can be useful, because what if in the next cycle this comes? So sequence will be again detected. Sequence will be, first this was detected and then again detected. So in next 3 cycles only sequence can be detected, from C to D, D to E, and then E to again C. I can go in this manner, because these two ones can be of use. So again it will look for the best case. So that's the difference only. Here the major difference comes. Then when the sequence is detected, in the previous case I was starting right from the beginning when sequence was detected. But here, if sequence is detected, it will again look for the best case, which is this. So that's why it is going in this manner. Right? Understood? Now what about other cases? These cases will be same. Because if 0 is applied, it will have to start from the beginning. If you are at B, 0 is applied, then 0 it cannot see anywhere. So it will start from the beginning again. What about C? If 0 is applied, it need to go ahead. If 1 is applied, it will look for the best case. What is the best case? 1, 1. C itself. So if 1 is applied, it will come back to C only. What about D? If 1 is applied, it will go to the next state. But if 0 is applied, it will look for the best case. That is 100, not anywhere. 00, not anywhere. Single 0, not anywhere. So it will have to go back to state A. So if 0 is applied, output will still be 0. And for E also we have analyzed. So I hope you are understanding the point, right? Let's do it again for this sequence, which is 1010. We are going to do it for 1010. Okay. So I am currently at state A. If applied input is 1, then I am happy. I can go to the state B. This is the case when overlapping is allowed. If applied input is 0, then I am happy. I can go to the next state. If applied input is 1, then I am happy. I can go to the next state. If applied input is, now I will check. So if I am at B, that means 1 has been detected. If I am at C, then 10 has been detected. If I am at D, that means 101 has been detected. Now at D, if 1010 has been detected, next input bit is 0. If next input bit is 0, then what it will say? That my output will be 1 now. Output will be 1. There is no doubt about that. But it will look for the best case now. And what is the best case? Do you see 010 anywhere? No. Do you see 10 anywhere? Yes. I see 10 to the state C. So it will go to the state C. So if applied input is 0, then sequence is detected, it will give output 1, but it will go to the best case, which is 10. So it will come back here, right? And if the applied input was 1, so eventually it have to look for the best case only, output will be 0. If applied input is 1, output will be 0. But again it will look for the best case, which is the best case? 011, do you see? No. 11, do you see? No. Single 1, do you see? Yes, single 1 I see. That means I will go here. So if applied input is 1, my output is 0 only, but I can go to the state B. Say yes or no, right? Let's analyze the same for the rest of the states, which is this. If applied input is 0 initially, I will come back to A only. After 1, if applied input is 0, I am going ahead. If applied input is 1, so I will look for the best case. Which is the best case? Drop 1 bit. Do you see 1 anywhere? Yes, I see 1 at B only. So if applied input is 1, I will come back to B only. Do you got this point? 1, 1, drop 1 bit. You see, if 0 is, after 1, if 0 was applied, I need to go to the next state only. But if 1 is applied, I will see for the best case. Drop 1 bit. Where is 1? Where is 1? In the state B itself. So if applied input is 1, give output of 0 and come back to state B only. This we have already analyzed. Now in the state C, if applied input is 1, I will go to the next state. But if applied input is 0, I will look for the best case. Which is the best case? Do I see 00 anywhere? No. Do I see a single 0 anywhere? No. So I will have to go to the state A only. There is no other chance I am having. So if applied input is 0, then I will give my output equals to 0 and will go back to state C. And for D only we have analyzed, right? For D, we have already analyzed, right? Did we see another example? So this you will do on your own, but later on you will do. So yeah, that was the scene for Mealy machine. So this we have done for Mealy machine. Overlapping allowed and overlapping not allowed. Murray will be exactly the same, but what is the case in Murray? In case Murray, the output is already written. So I will be starting what I need to detect. The example is 11011 11011. This I need to detect, right? Now I will start from state A, considering my output is 0. Why I already consider my output to be 0? Because if I am starting, then certainly I am not getting output 1, because I need to detect 5 bits. I need to detect 5 bits, and if I am starting at the first, I will get only 1 bit. So no matter whatever the bit I get, whether I get 1 or 0, certainly my output is going to be 0 only, no? Because I need to detect 5 bits. So for that, if my applied input is 1, then I can go to the next state. Again my output will be 0 only, right? If my applied input is 1, I can go to the next state, but again output will be 0 only. 1, 1. If my applied input is 0 now, then I can go to the next state. I can go to the next state, but again output will be 0. If my applied input is 1, then I can go to the next state, but again my output will be 0. Okay, I should have made it a bit more small. Yeah, so what I have applied 1101. Again, if I apply 1, I can go to the next state. A, B, C, D. 1 is applied, 1 is applied, 0, 1 is applied, and again 1 is applied. So I can go to the next state F. Now my output will be 1. Say yes or no. 1, 1, 0, 1. Till this point your output was 0. If again 1 is applied, you will go to the next state, but now your output is 1. So that's why I said you require one more stage. Okay, so better here only I can make no issue about that. You will get output 1. So you need one more stage here. You can see here you required A, B, C, D, E, but here you require one more stage, that is showing that your output is 1 now. So you started with A, output was 0 only. Why output is 0? Because you know that in one state only you are not going to get output 1. Then if bit 1 is applied, then you are happy, you can go to the next state. Then again 1 is applied, you are happy, you can go to the next state. Again 0 is applied, you are happy, you can go to the next state. Again 1 is applied, you are happy, you can go to the next state. But here what do you see? That now my output will become 1, because the sequence has been detected. Okay, right? Now let's see, if I am at state B, that means certainly 1 has been detected. If I am at state C, that means 1 1 has been detected. If I am at state D, that means 1 1 0 has been detected. If I am at state E, that means 1 1 0 1 has been detected. And if I am at state F, that means 1 1 0 1 1 has been detected, right? Now let's start with A again. If 0 is applied, I will come back to A only. In front of B, if I am at B, then certainly 1 has been already there. If 0 is applied, I will look for the best case. No best case is there, I will have to go to A only. What about C? If I am at C, that means 1 1 has already been applied. If 0 is applied, I am going to the next state. If 1 is applied, I will look for the best case. What is that? C itself. So I will come back to C only. Now if I am at D, if I am at D, that means 1 1 0 has been applied. 1 1 0 has been applied. If I am at D, that means 1 1 0 has been applied. If 1 is applied, I am going to the next state. But if 0 is applied, I will look for the best case. 1 0 0, can't see anywhere. 0 0, can't see anywhere. Single 0, can't see anywhere. Again I will have to start from A only. For the applied input 0, right? What about this one? 1 1 0 1. So if applied input is 1, I am going to the next state. But if applied input is 0, I will look for the best case. What is that? 1 0 1 0, see anywhere? No. 0 1 0, see anywhere? No. 1 0, see anywhere? No. Single 0, see anywhere? No. So if applied input is 0, you will have to again start from A only. Now in this case, 1 1 0 1 1. The case is overlapping not allowed. Overlapping not allowed. So you are supposed to start right from the beginning. Will you start from A only? No, you need to check. No. If you are at F, then 11011 has already been detected. If 0 is applied, if 0 is applied, if 0 is applied, then certainly you have to start right from the beginning. I am not looking for the best case here. I am not looking for the best case. If 0 is applied, if this has been detected, this is gone now, right? Now my new journey will start. My new journey is starting from 0. So my new journey is not matching from anyone here. I will repeat this point. Listen to me very carefully. If 11011 has been detected, that means this loop is gone now, right? There is no use of this loop, because this is the case of overlapping not allowed. In case of overlapping not allowed, if 1 is detected, then it is gone. We'll start our new journey. We are starting our new journey. If I am starting my new journey and I get 0 there, so I will match. If in any of the previous state am I getting 0? No. Then I will have to start again from A only. But if I get 1 in the next state, if I get 1, my applied input is 1. So will I start from A again? No, I will start from B. Mark my point, I am not overlapping here. This is not overlapping. These bits are gone. But my next applied input is 1. My next applied input is 1. If my next applied input is 1, what will I think? Why should I start from A? Because directly I can start from B only. No, because B is saying that I am already at state B. That means already 1 has been applied. So if 1 has been already applied, then I should start from B only. No, say yes or no. This is not overlapping. If I was overlapping, then I would look for 1 1, and 1 1 is here. I would go to C, not to B. But I am going to B because these bits are gone now. What is left? This 1 is left. Now this 1 is left. Now you will see what is the best case for this 1. The best case for this 1 is B. So that's why you are going to B. If my applied input is 1, what I will think? Yeah, this is my new journey. Journey is new now. But if I applied input is 1, then I will go to that shop which is already having 1. Why should I go to the shop where I started? No, I will go to the shop where it is already having 1. So I am going there. This is not overlapping. We will see the case of overlapping. That will be different. So this was not the case of overlapping. Okay. So I hope you must have understood. Now in this example only we will see the case of overlapping, because guys get confused in this particular example. Okay. So let's see the case of overlapping. So A0 will be there. So what I need to detect? 1 1 0 1 1. So if applied input is 1, I will go to the state B. If applied input is 1, I will go to the state C. If applied input is 0, I will go to the state D. If applied input is 1, I will go to the state E. And if applied input is 1 again, I will go to the state F, giving the output equals to 1. So 1 1 1 1 1 0 1 1 0 1 1 1 0 1 1. There you go. Okay. Now in case of BCD, everything will be same. Until the sequence is detected, everything will be same only. So no need to worry about these cases. But let's analyze it. If applied input is 0 itself, I will come back here only. Right? If applied input is 1, in case of B, if applied input is 1, then I am going ahead. But if applied input is 0, if I am at B, that means 1 has been already detected. If 1 is applied, I am going ahead. If 0 is applied, I will look for the best case. I am not getting anywhere. So I will come back here only. In case of C, if I am at C, that means 1 1 has already been applied. If I get 0, then I am going to the next state. If I get 1, that means I will look for the best case. That is 1 1 only. So I will come back to C only. Applied input is 1, I am coming back to C only. What about this? 1 1 0. If applied input is 1, I am going to the next state. If applied input is 0, I will look for the best case. 1 0 0, not getting anywhere. 0 0, not getting anywhere. Single 0, not getting anywhere. I will have to go to state A only. What about this? 1 1 0 1. If I am at state C, that means this has been detected. If I apply 1, I will go to the next state. If I apply 0, I will look for the best case. 1 0 1 0, not getting anywhere. 0 1 0, not getting anywhere. 1 0, not getting anywhere. Single 0, not getting anywhere, that means I will have to start from the beginning only. Now the interesting thing will come. So this is the most important part which is required. So now let's see for this part. So sequence has already been detected, that you know, 1 1 0 1 1. But if the applied input is 0, it will look for the best case only. It will look for the best case only, no? If applied input is 0, it will again look for the best case. That my sequence is not detected. If applied input is 0, my output will be 0 only. But what if I get the best case? That what if I get 1 1 0 1? If I get 1 1 0 1, I can come back here. But am I getting that? What I am getting? 1 0 1 1 0, not getting anywhere. 0 1 1 0, not getting anywhere. 1 1 0, yes, I am getting here. So I will go to the state D. If my applied input is 0. If my applied input is 0, then this is the scene, that this is the scene. So 1 1 0 is already there. 1 1 0 is already there. What if in the next cycle 1 1 comes? So this was already detected, 1 1 0 1 1 0. This will also be detected. So this 1 1 0 has been used. Are you getting this point? This 1 1 0 has been used. So that's why I went to the state D. Now if applied input was 1, then again I know my output is not going to be 1. My output is not going to be 1, but again I will have to look for the best case, because in case of overlapping allowed, my final state will always look for the best case. In case of overlapping allowed, my final state will always look for the best case. But in case of overlapping not allowed, it will have to think. But in case of overlapping allowed, my final state will always look for the best case. If you are not understanding these points, I highly recommend you to watch the video again. You will understand. But this is the best way it can be taught. Okay, you can watch n number of videos on this particular topic, but I guess this is the only explanation where I have put like all the possible chances the way I can explain. So I hope you are understanding. So now again it will look for the best case, which is 1 0 1 1. It is getting anywhere. 1 0 1 1, no. 0 1 1, no. 1 no. 1 1, yes. 1 1 it is getting. So 1 1 it is getting at C. So it will go to C. Okay, and this I can make better. From here I can make it. It would have gone to D for applied input 0. If applied input is 1, it will go to C. Because these two 1 1 can be used in the next cycle. 1 1 0 1 1. So these two 1 1 can be used. What if 0 1 1 is applied? So these two 1 1 can be used. So that's why it is going here. So this is the overlapping allowed Moore. So this is how we make it. Are you comfortable with this analysis? No, you are not comfortable, I know. But I highly recommend you to watch it again. Once you feel like that you are comfortable, then try this. Overlapping not allowed Moore. Overlapping not allowed Moore. What you need to detect? 1 0 1 0. Look, if they are going to ask you to design, then mostly they will ask for 3 bits only. For 5 bits, that's the maximum. Okay, that's the maximum limit. If they are asking to design, to detect they can ask anything, because detecting is very easy. If I am asking you to detect the sequence here, can you detect it? Yes, you just need to see when I am going to the next state. If 1 is applied, I am happy going next state. 1 is applied, again 0 is applied, 1 is applied. Just as 1 is applied, my output is becoming 1. So that's it. This is detected. It is very easy. Right? Whenever it is detected, output is 1. So detecting is very easy. But to design, you need to think. So here we are designing. Right? So now we are designing for overlapping not allowed Moore. So initial state, if 1 is applied, I am happy. I will go to the next one. If 0 is applied, I am happy. I will go to the next one. If 1 is applied, I am happy. I will go to the next one. And if again 0 is applied, then I am super happy and I will give my output equals to 1. So if I am at B, that means 1 has been detected. If I am at C, that means 1 0 has been detected. If I am at D, this has been detected. If I am at E, this has been detected. Let's talk about this point at B. If applied input is 0, I am going ahead. If applied input is 1, I will look for the best case, which is 1 itself. So I will come back here. And what about this A? If 0 is applied, I will come here only. But we cannot write output here. If 1 is applied, then I will come back to state B only. 1 is applied, I will come back to state B only. Right? What about this case? about C. If 1 is applied, I am going ahead. If 0 is applied, I will look for the best case. Double 0, do you get anywhere? No. Single 0, do you get anywhere? No. Then I will have to go back to A only. For which input? For applied input 0. What about D? 1, 0, 1. If 0 is applied, I am going to the next state. If 1 is applied, I will look for the best case. 0, double 1, no. Double 1, no. Single 1, yes. I am getting single 1 at B. So from D to B, I will be going. Single 1. I get single 1 at B. So from D to B, I will be going for applied input 1. Now, last case. What is the scene here? Overlapping not allowed. That we need to remember, overlapping not allowed. 1, 0, 1, 0. Sequence has been detected, that's for sure. Sequence has been detected, that's for sure. Now, if 1 is applied, if sequence has been detected and overlapping not allowed, that means this is gone. There is no use of that. Sequence has been detected, overlapping not allowed, this is gone now. Because in case of overlapping not allowed, if sequence is detected, then whole register gets cleared. Whole register gets cleared. So it is clear now. So now only you have to look at 1. Overlapping not allowed, Moria. So now you only have to look at 1. This is gone, there is no use of that. What you will say? That why should I start from the beginning? Because 1 I am getting in state B only. So if applied input is 1, then I will go to state B. If applied input is 1, I will go to the state B only. And if applied input is 0, then I am not getting any good case here. So then I will go to state A again. Are you getting this point? This is the case of overlapping not allowed only. This is the case of overlapping not allowed. Are you getting this point or not? Are you understanding? Overlapping we are not allowing. If I was allowing overlapping, the case would have been different. Here I would look for 00. I am not getting 00. Then I will look for 1000. That also I am not getting. 0110 also I am not getting. But in case of 1, if overlapping was allowed, then I would look for this case 101 that I am getting at D only. I would go to D if overlapping was allowed. But here overlapping is not allowed. That means this 1010 is gone. I am only looking at 1. So where do I get 1? I get 1 at B. So I am going at B. If you are thinking with good amount of patience, if you are thinking with a cool brain, you will be able to understand it. Right? And to be very honest, in GATE examination, till now, they did not ask any question on designing. But certainly they can ask. Okay, this question is certainly on cards. It can any day come. In GATE examination, what do they ask? Usually to detect the sequence. And you people directly detect the sequence. They don't even ask whether it is overlapping or non-overlapping. And 9 out of 10 students, or I would say 10 out of 10 students don't even know that state diagram will be different for overlapping and non-overlapping. So that is something that is missing. Usually we don't see lectures on FSM much on depth, but this is the maximum depth they can go. Even in the interview, this is the thing they will ask, not more than that. Okay, so I hope you are getting comfortable. If you are not getting comfortable, I highly recommend to watch the video again. You will understand everything slowly. Now your task is to design the same, but for the case of overlapping allowed. Overlapping allowed, Mure, you need to detect 1010. Pause the video, do it on your own. Okay, so let's start doing it. Should be very easy for you. If 1 is applied, go to state B, output still 0. If 0 is applied, then I am going to state C. And if again 1 is applied, I am going to state D. And again 0 is applied, I am going to state E. And then if again if again 1 is applied, 1010. Okay, sorry. Here only I am getting output 1. So here I was detecting 1, here I was detecting 1, here I was detecting 1, here I was detecting 10, here I was detecting 101, and here I was detecting 1010. Say yes or no, right? 1010. Now let's start from A. If applied input is 0, I will come back here only. If applied input is 1, here. If applied input is 0, I am going to the state C, and if applied input is 1, I will come back to B only. This we have already seen. What about C? If applied input is 0, then I will look for 0 0 not getting, I look for single 0 not getting, then I will have to go back to state A. And if applied input is 1, I am going ahead, right? What about this 1 0 1? If applied input is 0, if applied input is 0, then I am going ahead, and if applied input is 1, if applied input is 0, I am going ahead. If applied input is 1, I will look for the best case. 0 1 1 not getting, double 1 not getting, single 1 yes getting. So if I am getting single 1, so I will go to the single 1, that is B. So if applied input is 1, I am going here. Now E comes. So sequence has already been detected, but this is the case of overlapping allowed. So you will take this in action 1 0 1 0. So if applied input is 0, you will look for the best case. 0 1 0 not getting, 1 0 0 not getting, double 0 not getting, single 0 not getting. So certainly I will again have to start from A only in case of overlapping allowed if input is 0. But if input is 1, then again I will look for the best case. So 0 1 0 not getting anywhere, 1 0 1 yes getting in the state D. So I will go to the state D if applied input is 1. So I hope you are able to do it on your own now, because now this 1 0 1, this combination is useful. What if the next bit is 0? Then again I am detecting my output, right? So I hope you are understanding. I hope you must have done it. So these examples we have seen. First we started with 1 0 1 0, overlapping not allowed Mealy, overlapping allowed Mealy, overlapping not allowed Moore, overlapping allowed Moore, overlapping not allowed Mealy, overlapping allowed Mealy, overlapping not allowed Moore, and overlapping allowed Moore. Okay. Do this example. Only design Mealy machine. You don't need to design Moore. Moore you can design on your own. Do the example 1 1 0. These kind of examples can be asked in your interviews. In gate examination, anything can come. Mostly they will ask this example only. You need to design overlapping allowed Mealy machine to detect the sequence 1 1 0. Okay. So what I will start from? I will start from A. If 1 is detected, then I am happy and will go to the next state. If again 1 is detected, I am happy and I will go to the next state, and then here I will wait. So 1 1. Now if 0 was there, so I would start right from the beginning only, giving the output 0. If in this case 1 is already detected, if I get 0, I will look for the best case. I will look for the best case. Do I get 1 0 anywhere? Sorry, do I get 0 anywhere? No, I do not get any 0 anywhere. So I will go to the state A again. Because if 1 is applied, if 1 was applied here, after B, if 1 was applied, I am going to C only. Now in case of C, if 0 is applied, that means sequence has been detected and you will have to start your journey again. This is overlapping not allowed actually. This I am doing for overlapping not allowed. Overlapping not allowed. So here 1 was detected, here 1 was detected. So if you apply 0, then your output will be 1 and you will have to start your journey again. But if you apply 1, then you will look for the best case. What is the best case? Double 1, do you get anywhere? Yes, I get double 1 in C itself. Basically in C you are getting 1 1. If you are getting 0, that means your journey was done and you have to start again, because this is the overlapping not allowed case. Overlapping not allowed case. In case of overlapping not allowed, just as the sequence is detected, you start your journey again. And in this case, if I am at C, that means I am at 1 1. If my input is 1, then I will look for the best case. What is the best case? Double 1. So double 1 where I am getting? At C itself. So at C itself. So if my applied input is 1, output will still be 0, but I will come back to C only. Understood? Let's start this one now. So these will be same only. There is no doubt about that. The changes will be there in the final state when it is detected, right? This I am making same. There is no doubt about that. So if I am at B, then 1 has been detected. If I am at C, then 1 1 has been detected. If my applied input is 0, then I know that sequence has been detected. If my applied input is 0, that means I know that sequence has been detected. But I will look for the best possible case. What is the best possible case? 1 0, do you get anywhere? No. Single 0, do you get anywhere? No. So again you will have to start from the beginning only. Are you getting this point? Here this was the case for overlapping allowed. overlapping allowed. So I will look for the best case that my sequence is detected. If my applied input is 0, my sequence is detected, but I will look for the best case because this is the case of overlapping allowed. So even in the final state I am looking for the best case. Even in the final state I am looking for the best case. So my best case is 1 0. Do I get anywhere? No. Do I get a single 0? No. So I will have to start from A only, right? And if 1 is applied, then again I will look for the best case only, because eventually my output is going to be 0. So again look for the best case. 1 I get anywhere? Yes, here I get 1. So if 1 is applied, my output will still be 0, but I will come back to C only. That's the way I will be going. Okay. What do you understand here? What do you understand here? That these both are equal. And think with intuition, no. 1 0 in any sequence, whether it is overlapping allowed or not allowed, the answer will be same, no. Let's just say I am taking this sequence 1 0 1 1 0 1 1 1 0 1 0 1 0 1 1 0. I am saying you need to detect 1 1 0 in case of overlapping not allowed. Overlapping not allowed, 1 1 0 1 1 0 1 1 0 and then 1 1 0 in case of overlapping not allowed. Now I am saying detect 1 1 0 in case of overlapping allowed. Still the answer will be same. Still the answer will be same only. Overlapping allowed. Even if overlapping is allowed or not allowed, the answer will be same. Why is that so? Why the answers are same? Why these answers are same? Because there is no symmetricity in the sequence. Previous examples we took 1 0 1 0. You can see there is symmetricity. That again 1 comes, then again 0 comes. So yeah, these two sequences could be there. But what about 1 1 0? Again you have to apply 1 1. So 1 1 0 one sequence is detected, 0 1 1 is not the sequence. Again you have to apply 0 again. So this is the sequence detected. So overlapping is there or overlapping is not there, both are same only. So just by looking at the examples, if you just write down 1 1 0, you will realize that to again detect it I need 1 1 0 again. So there is no symmetricity. So for overlapping allowed and overlapping not allowed, both cases will be same. So these kind of questions can be asked in your exam, in your interview, that you have made for overlapping not allowed, do you need to make it for overlapping allowed? No, because there is no symmetricity, and for both of them the cases will be same. So both diagrams are exactly the same. Okay. So that's it about our FSM. We will see one more example that is very advanced. Okay, that is very advanced. So in this example, what you need to do? You need to design an FSM which will detect the sequence 1 1 0 0 1 0 1 0 and 1 0 1 1 0 0 1 in one FSM only. You need to design one FSM, only one FSM, which will detect 1 1 0 0 as well, 1 0 1 0 as well, 1 0 0 1 as well. Let me take an example. 1 1 0 0 1 0 1 0 1 0 1 0 0 1 0 0 1. Okay. So this is your input. This is your input, and this input I am giving to a FSM which detects these three sequence. So if I get any of the sequence, it will give me high output. So 1 1 0 0. This is the case for overlapping allowed. I am saying, okay, overlapping allowed. So 1 1 0 0 it will give me high output. Then 1 0 1 0 it will give me high output. Then again here also I can see 1 0 1 0, again it will give me high output. Again 1 0 1 0 I can see, again it will give me high output. 1 0 0 1 I can see, 1 0 0 1 I can see, again it will give me high output. Okay. Then 0 1 0 0 nothing, 1 0 0 1 again I can see, again it will give me high output. So this FSM, what this FSM does, it will detect all these three combination. If in the input stream you are getting 1 1 0 0 or 1 0 1 0 or 1 1 1 0, it will detect all of them and will give high output. So this is what it means. Pause the video, try doing it on your own. I know you will get it wrong. Okay, there is no doubt about that. You will get it wrong only if you haven't studied it. But still, let's try it. Overlapping allowed, overlapping not allowed. Just do it for these two cases. Design for both of the cases. Design Mealy only. Okay, because Mealy is more important. Mostly Mealy is asked. More they will not ask. Okay, so anything you can design, but let's start with Mealy. Okay, so let's design Mealy only for this case, which is, this is very rare. There is only 0.5% chances that this can be asked. But what if they ask it? So we are going to do one example. Pause the video. I will also pause the video, drink some water. Then I will come back and we will start analyzing this. Okay. So let's do it. You start doing it on your own and then we will see what we can do in this kind of questions. Okay then. Yeah. So let's see this example. So first we are looking at overlapping allowed. So we need to detect 1100, 1010 and 1001. So I will start from a random state, that is I am assuming state A. So first I will look at 1100. I need to detect 1100. So for that, if applied is 1, then I will go to state B. Applied input is 1, I will go to state C. If applied input is 0, then I will go to state D. Let's stop it here once. Okay. So if I am at B, that means 1 has been detected. If I am at C, that means 1 has been detected, and if I am at D, that means 110 has been detected. Okay. Overlapping allowed. This is the case of overlapping allowed. Mark that this is the case of overlapping allowed. Which is more difficult? Overlapping allowed is easy. Not allowed is easier than overlapping allowed, I guess. So we can solve in any manner. So let's do it. So if I'm at B, that means 1 has already been detected. If I'm at C, that means 11 has been already detected. And if I'm at D, that means 110 has already been detected. Now I need to detect 1010 in the same FSM. What do you think? Will I start from A? No. What is the first bit? First bit is 1 only. So if I have the state where 1 is already detected, so why I should not start from that state only? So I will start from B, because in B 1 has already been detected. Now my next task is, if 0 is coming, then I will go to next state, which is E, giving the output 0 only. Are you getting this point? Again, let's see it. I need to detect 1010 now. In state B, 1 has already been detected. In state B, 1 has already been detected. Here, this is my starting point. But why would I start from the starting point again? Why I am not starting from the starting point again? Because I know one thing, that my first bit has to be 1. My first bit has to be 1. So it is already there in state B. So I will start from state B only. No. So 1 has already been detected. In the next cycle, if 0 comes, then I will be happy and I will be going to the next state. Output will certainly be 0, because until I detect 1010, till that point I am not going to give my output as 1. So E means 1 and 0 has been detected. B means 1 has been detected, and E means 1 is already detected and then 0 is also detected. So E means 10 has been detected. Right? Now you need to detect 101. So after 10, if 1 is applied, then I will go to next state. Basically the thing is, if the question was you need to design for this, how would you design? Starting from A, then I would go to B. If starting from A, if 1 is applied, I will go to B. Then if 0 is applied, I will go to C. And then if again 1 is applied, I will go to D. The same thing we are doing here. Just C is replaced with E. C is replaced with E. And D is replaced with F. You can check the same thing we are doing. 1, 0 and 1. 1, 0, 1. 1, 0, 1. At the last point, I will stop. Say yes or no. From 1 is detected, 0 is detected, 1 is detected. Here 1, 1, 0 was detected. Now in the last state, if 0 is coming, then what I will do? If 1 is coming, what I will do? That I will check. Okay. So E means 10. And what does F mean? F means 101. Now if 0 comes, then what I will do? If 1 comes, then what I will do? That I will check. So this is the case for second one. What will be the case for third one? Third one will see if I am getting 100 anywhere or directly 1001 anywhere. No, here you are getting 110, here you are getting 101. But are you getting 10 anywhere? Yes, I am getting 10 anywhere. So I will start from state E only, because already I am having 10. Now if my input comes 0, then I am happy and I can go to the next state, that is G. Say yes or no. So what G will represent? G is representing 1, 0, 0. This is 10 and another 0 is coming, so that means 100, G is representing 100. Now let's go to D. So across D, if 1 comes, across D, after D if 1 comes, then what it will say? That sequence is not detected, your output will be 0 only, but I will look for the best possible case because I am in overlapping allowed. So what will be the best possible case? 101. Yes, I can see 101 here. I can see 101 in case of F. So I will go to F directly. Say yes or no. If my applied input after 110, if my applied input is 1, then sequence is not detected, but I will go to F because 101 I can already see. The best case is 101, which I can already see in F. Now in case of D, if 1100, if this is detected, if next bit is 0, so my sequence is detected now, 1100 is detected, the job for 1100 is done, but I will look for the best possible case because this is the case of overlapping allowed. So what is the best possible case? 100. Do I see 100 anywhere? No. Do I see 00 anywhere? Do I see 00 anywhere? No. Do I see 100 anywhere? Yes. I see 100 in case of G. So I will go to G. In case of G, I see 100. This is the best possible case. If 0 is applied, the best possible case is 100. So 100, where do I see? In case of G, I see 100. So if applied input is 1, sorry, if applied input is 0, after 110, if applied input is 0, then my output will be 1. Sequence is detected. 1, 1, 0, 0. Sequence is detected, but I will go to the state G because G represents 100. G is representing 100. So this 100 can be useful for me. So that's the cycle for first one, right? Let's think about the next one now. What will be the next? Let's think about G now. So at G I am having 100. At G I am having 100. If next bit is 0, if next bit is 0, what G will think? That sequence is not detected because job was to detect this sequence, but sequence is not detected. Now I will look for the best possible case. 000, do I see anywhere? No. 00, do I see anywhere? No. Single 0, do I see anywhere? No. I will have to go to the state A only. So now I will go to state A. Let's use another color of pen. So it will say that I will go to the state A. If applied input is 0, giving the output equals to 0 because sequence is not detected. Now, if the applied input is 1, if the applied input is 1, what it will say? That yes, sequence is detected, but I will look for the best possible case. Do I see 0001 here anywhere? No. Do I see 1001 anywhere? Do I see 01 anywhere? No. Do I see single 1 anywhere? Yes. I see single 1 in case of B. So if 1 is applied, my output will be 1 and I will be going to the state B. There you go. This is how you design it. Okay. Now let's think about the case. Let's pick this pen. Now let's think about the case F. So 101. If applied input is 0, if applied input is 0, you will say that yes, sequence has been detected because 1010 was my task. So if applied input is 0, sequence has been detected, but where will I go? Do I see 010 anywhere? No. Do I see 10 anywhere? Yes. I see 10 in case of E. So from F2 I will go to E. If my applied input is 0, giving the output equals to 1. Why output is equals to 1? Because sequence has been detected. If my applied input was 1, if my applied input was 1, that means sequence has not been detected. But I will look for the best possible case now. Best possible case is 011. Do I see 011 anywhere? No. Do I see 11 anywhere? Yes. That is the state C. So from F to C I will go. If my applied input is 1. But sequence is not detected, so I will give output 0. So here, how many ones you can see? If this state diagram was given in front of you, let's remove everything off. Let's remove all these off. But they will be used later on. So let's keep it. But forgetting about this 111 101 101 if this state diagram was given in front of you, would you be able to understand that how many sequences are detected here? You will see the number of ones. Number of ones, 1 time, 2 time, and 3 time. So that means certainly 3 sequence has been detected. If you see number of ones 3 times, 3 sequence has been detected. Then you can start from here. 1100, 1100. What could be the other sequence? You start from here. 1011, 1 0 1 0. You started from here 1 0 1 and then 0. So next sequence is 1 0 1 0. What about the next one? You can see here 1 0 0 0. Sorry. Yeah, 1 0 0 and 1. You see this cycle 1 0 0 and 1. So if I am moving ahead in the states, that means my sequence is being detected. So finally when it is becoming 1, at that time my complete sequence has been detected. So 3 times I can see 1, that means 3 sequences are being detected here. In the examination it is very rare that they will ask you this particular diagram. They will only ask, what they can ask, that I need to design a FSM which will detect these 3 sequences which are 1 1 0 0, 1 0 1 0, 1 0 0 1. How many flip-flops you will require? You need to design an FSM which will detect this given sequence. How many flip-flops you will require? How many states are there? 1 2 3 4 5 6 7. 7 states are there. Certainly you would require 7 states are there. That means you require 3 flip-flop. That would be your answer, that I require 3 flip-flop. Okay, so here I am going to write it. Total states are 7. This diagram is not completed, although total state 7, required flip-flop are 3. Tell me one thing, do you need to make this state diagram to get to know required flip-flop? No. I will just see A to B, B to C, C to D, then I will write down the conditions. Then I know next I need to detect 1 0 1 0. So 1 is already there, so 1 0 1 and another 0 that can be detected from the final state. And 1 0 0 1, so 1 0 is already there, so another state I would require. So I will get to know the state, directly I will get to know the state, right? Because I did not make the complete state diagram to name these states. We will see this example again in case of overlapping not allowed. There I will tell you, first I will make all the states only. I will make all the states only. There you can get to know that there will be 7 states only. Okay, but this diagram is not completed. Why it is not completed? Because we have taken only, if I am in state A and applied input is 1, then I will go to state B. But what will happen if applied input is 0? I will come back to state A only. What about B? What about B? If I am at state B, that means 1 has already been there. If applied input is 1, then I am going to the next state. If applied input is 0, I will look for the best case which is 0 only. So I will have to go to the state A. So if applied input is 0, then I will go to the state A. What about this? What about C? If applied input is 0, I am going to the next state. If applied input is 1, I will look for the best case which is 1 1. So I will come back to C only. So if applied input is 1, I will come back to C only. Okay, come back to C. For D we have completely analyzed. For D we have completely analyzed. For 0 as well and for 1 as well. For F we have completely analyzed. For G we have completely analyzed. For E as well we have completely analyzed. For 1 as well, for 0 as well. If 1 is there, then 0 is there. This also we have analyzed. Oh, wait a second. In case of B as well we have analyzed that we don't need to go back here. Right? This is the issue. Really sorry for this mistake. In case of B, if 0 is applied, I am going to the state E, not to state A. Okay. In case of B, you can see if 1 is applied, I am going here. 0 is applied, I am going here. So state B is already analyzed. What in case of C? If 0 is applied, I am going here. If 1 is applied, I am coming back. Right? For state D, both inputs are there. State G as well, both inputs are there. For state F as well, both inputs are there. Okay. So that's it. This is the complete cycle. So this is how it will look. I know it is complex, but if they are asking any short question from it, you will be able to answer. That's for sure. But if you have studied it thoroughly, if you have put good amount of concentration, then you will be able to answer this as well. Let's try making for overlapping not allowed. It would be easy only. What I need to detect? 11001010, 1100, right? 11001010, 010, and then 1001, 1001. So let's start from A. First I will look at this sequence only. So if I am getting 1, I am happy. If I am getting 1 again, I am happy. If I am getting 0, I am happy. And at D I will see if I get 0 what I will do, if I get 1 what I will do. So here what I get to know that till B I am having 1, here I am having 1 1 and here I am having 1 1 0. So till this point I know that from D I can get 0 as well or 1 as well. So I don't require further stages. If I get 0, detected. If I get 1, then I will go back to some of the previous state. So here I require 4 states that I know. What about the next one? 1 0 1 0. So it will start from B only because 1 is already there. So it will start from B. So B to E it will go. B to E it will go. If applied input is 0. And if applied input is 1, if applied input is 0, output will be 0. And if applied input is 1, it will go to F. That means if it is at E, that means it is at 1 0. And if it is at F, that means it is at 1 0 1. So now if my applied input is 0, then sequence is detected. If my applied input is 1, then I will see what will happen. But certainly I do not require any further stage. So that also I know here. Say yes or no. Now what about the next one? Next one I require 1 0 0 1. So 1 0 is already there. 1 0 is already there. Right? 100 is there? No, 100 is not there. So 1 0 is already there. So what I will do? From E to G I will go. If applied input is 0. Here at G I am already having 100. 1 0 0. At G I am already having 100. If 1 is applied, sequence is detected. If 0 is applied, then something else will happen. But certainly I do not require any other stage. That's for sure. I do not require any other stage. That's for sure. So for that, I would know that I only require till stage G. So here I can get to know that I require 7 states. 1, 2, 3, 4, 5, 6, 7. I require 7 states. In case 7 state, I will be able to make it. Say yes or no. If it was Murray, then how many states you would require? If it was Murray. So this would be 1 0 0. G is 1 0 0. This would be 1 0 1 and this would be 1 1 0. So 1 stage for this, 1 stage for this and 1 stage more for this. 1 more stage will be increased. Say yes or no. 1 more stage will be increased. Because in case of Murray, you write down your output here only. And we already saw that in case of Murray, 1 stage is already increased. Why is that so? Because the final input also you need to apply and then your output will be 1. So here in case of Murray, 1 more stage will be increased. So in case of Murray, you would require 10 stages and for 10 stages you would require 4 flip-flop. Right? So this you can tell. So this is the scene now. Now let's check for D, G and F. In case of G, it is 1 0 0. Okay. Now for D, if 1 0 1 is applied, if 1 is applied, I would get to know that I will not get my output 1. My sequence is not detected. So if sequence is not detected, certainly I will look for the best possible case. If sequence is not detected, certainly I will have to look for the best possible case. Do I get 1 0 1 anywhere? Yes. In case of F. So applied input is 1, then output is not detected. Until output is not detected, it will not be clear. Just as output is detected, then it will be cleared. Do you remember this point? Just as your sequence is detected, not output, sorry. Just as your sequence is detected, then it will get clear. If your sequence is not detected, it will not get clear. It will look for the best possible case only. So if I am at state D, and my applied input is 0, that means the sequence has been detected now. If sequence has been detected, then I need to start my journey right from the beginning. Say yes or no. So sequence is detected, so I will start my journey right from the beginning. So if my applied input is 0, then my output will be 1 and I am starting my journey right from the beginning. So this was the scene. Let's take the example of G now. So in case of G, we are at 1 0 0. So if 0 is coming, that means sequence is not detected. And if sequence is not detected, it will look for the best possible case. 0 0 0 not getting, 0 0 not getting, single 0 not getting. So it will have to go back to A only. So if my applied input is 0, my output will also be 0. But if my applied input was 1, I am at G, applied input was 1, then the sequence has been detected. And if the sequence has been detected, you need to start your journey from the A only, from right from the beginning. So it will not look for the best case, because this is overlapping not allowed. Just as it is detected, everything is cleared. If everything is cleared, that means I will start my journey right from the beginning again. So here only I am writing, if my applied input is 1, my output will also be 1, and I will be starting with A only. So this is how we can write with comma. If applied input was 1, then output will also be 1, and I will be starting the journey from A. Do you get this point? Yes, you understand this point. So this was the case for G. What about F now? In case of F, 1 0 1 is there. If applied input is 0, that means sequence has been detected and I need to start my journey from A only. If applied input is 0, sequence has been detected, I am starting my journey from A. And if applied input is 1, what I will do? I will look for the best possible case. 0 1 1, do I get anywhere? No. 1 1, do I get anywhere? Yes. I get 1 1 in case of C. So the change of color should be there. So this was the case when 0 was detected, it was starting his journey right from the beginning. But if 1 is detected, it will start its journey from C. Why? Because sequence is not detected, and if sequence is not detected, it will look for the best possible case. And what is the best possible case? That is 1 1, and that you are getting in state C. So if applied input is 1, then output will be 0, but I will be starting my journey from stage C, because these 1 1 can be used for me. So I will be starting here. So this is the diagram for overlapping not allowed. We can see the cases for A as well. For A, if applied input is 0, then it will come back to this state only. And what about C? If applied input is 0, it is going ahead. If applied input is 1, it will come back to this stage only. For B, already there are 2. For E also there are 2. E also there are 2. F also there are 2. And D also there are 2. So here also there are 2. So this is the final state diagram. Okay. Let's move all these off. So this is the final state diagram of a overlapping not allowed Mealy machine. Okay. So I know these are complex, but if they ask you to analyze this, will you be able to analyze this? Yes. You can tell that there are 3 times 1, 1, 2 and 3. 3 times 1, that means 3 sequence has been detected. How will you read it? You just need to go in the next state, 1 1, then 0 and then 0. So 1 1 0 0. And if they ask you whether it is Mealy or Murray, you can directly see it is Mealy only. Whether it is overlapping or non-overlapping, you will get to know just as the sequence are detected, they are starting right from the beginning. That means certainly it is non-overlapping. Overlapping is not allowed, non-overlapping. And if they are starting somewhere in the middle, just as the sequence is detected, they are starting somewhere in the middle, that means it is certainly your overlapping allowed. And this is overlapping not allowed. So this is the way we need to analyze it. We need to make this diagram. This is the maximum limit they can go. They are not going far from this. Okay, so that's it about from my side about FSM. We can see few questions on FSM. Purely on FSM, we will see some problems. So 5 to 6 problem we will see, that will be based on FSM only. So okay, and that will be a good practice for you. So probably I will be adding up those videos in this particular video only. Just in this particular video, in roughly around 20 to 30 minutes, we can finish off those problems. Okay, so in this particular video only, I will be adding up those problems, or I can make a separate video. I will check that, and with that your FSM will be completed. Okay then, thank you very much.